Okay, so subnetting, it's not as hard as you have been brought or thought to believe. The only things that we do is we subnet IPv4 addresses, not IPv6. IPv6 has so many IP addresses, there's 390 something million per square meter of Earth, so we don't need to go there. So we do have to subnet IPv4 because they're pretty much out of IP addresses, so you have to use the public and the privates. So understanding that, there's the domains, you have to realize we start talking about breaking things down so that we have more of the usables that we have right now. So the first thing you have to learn is decimal dot notation, which is a decimal and then a dot. Or the ones that most likely people have seen is something like this, which is what we call a private IP address. So there's a decimal and then a dot. So that's decimal dot notation. That's pretty simple, easy to understand, right? Right? Good? So with this is the understanding that I'm going to start using X's instead of numbers. Flow through a little bit faster. That's the decimal dot notation, but then there's also something that people have been using is something that's called the slash notation. So that you would see like a /27. And then people can't figure out what this is actually containing. And so the fact is that IPv4 addresses have bits. There's 8 bits in every single octet. Each one is an octet. Underneath here is 8 bits, and they all have values. So dividing the fact is that every single one is divided by 2. It's pretty easy to understand. 1 bit, 2, 3, 4, 5, 6, 7, 8. All these numbers derive from, if you were to add them all up, the number that you would get is what? 255. So does that mean we have 255 IP addresses? No, because there's a 0. 0 is a number, so therefore instead of 255, I'll come this way, sorry. So instead of just having 255 IP addresses, you actually have 256. So 0 is a number, yes, 0 can be used. It's not here because you don't need a 0 in order to turn it. So if you turned off all these bits, what would you get? 0, because you don't have anything. But if you turn on 1 bit, depending upon which bit it is, it could equate to a certain number. If you want to get 3, you would add the first 2 bits. So that would be a /2. /1, 2, 3, 4, 5, 6, 7, 8. So every single octet has a possibility of 8. So if I want to get to a /27, what are the numbers that I can equate to find out or add to get to /27? So if I can only go to 8 here, I know I need 8, because 8 plus 8 is now 16. 8 plus another 8 is 24, and then now I need to go up to 3 more, so I turn on 3. The first 3 that I would turn on is 1, 2, and 3. So if I draw my line there, that means all these are usable. Break that down. All these are usable for the user portion. This is the network portion, so it would be the subnet mask would be the addition of these 3 products, which would be what? 128 plus 64 is 192. 192 plus 32 is 224. So if all 8 bits are turned on, for /27, all 8 bits gives us the number of 255, right? All 8 bits, 255. All 8 bits, 255. And then 3 bits, I just told you, was 224. That would be the subnet mask for a /27 network. Just by figuring out that the bits, each octet that's been turned on, gives you the subnet mask. That's how you find the subnet mask for any / notation. That makes sense? Okay. Now the math behind figuring out what the usable portions is a little bit harder, but the math behind it is 2 to the nth power minus 2. Or you can kind of understand that / notation like we did before with the /27. How many bits are turned on? Well, there's 27. We had 4 octets before, so we had 1, 2, 3, 4 octets, 8 bits per. So that means there's 8 here, there's 8 here, there's 8 here, plus how many here? 3. So how many bits are left over? 5. So because we know the max number is 8, right? So there's 5 bits that are left over. So we would replace this n with 5. 2 to the 5th power minus 2. So you can go 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So it would be 32 minus 2, which would give us 30 usable IP addresses. That's the math behind figuring out. Now, it's a little bit more complicated if you start to go down the math, but just to show you that there is a math behind this product. Now, there's an easier solution to the problem, is that we all know what 5 times 5 is. This is the 5 by 5 method that I've figured out. So we understand that 5 times 5 is 25. So if you have a slash 25, the easiest way to figuring it out is by use your hands. So you use 5 by 5 is 25, 26, 27, 28, 29. You just kind of go down and those are the most usable ones that we use. Slash 25, 26, 27, 28, 29. The same concept is involved with the numbers as well. So you have the bits, the 128, the 64, the 32, the 16, the 8, the 4, the 2, and the 1. So it's the same concept here. By 5 by 5 is right here. This is the biggest number that we can start off, so we'll start off there. So 5 times 5 is 25, and the biggest number, because of my thumb, is the biggest one, so it has to be 128. So for a slash 25, remember the 2 to the n power minus 2 theory, there's 128 IP addresses out there. How many are usable? Minus 2 would tell me that I have 126 usable IP addresses. And that's simple. So now we go through and think about it again. So let's say slash 29. I'm just thinking about it, so it's 555 is 25, 26, 27, 28, 29. You start to go down the same bit levels you did before, 128, 64, 32, 16, 8. So you have 8 IP addresses and 6 are going to be usable. Right? It's the same concept. So at any point in time, you need to figure out slash 25, slash 26, slash 27, slash 28, slash 29. Those are the simplest and easiest ones to figure out. Now if I did a slash 24 and up, that's where we need to go the opposite way. So knowing this, just as a quick scenario to see how fast you can do it after you've learned the 5 by 5 Downey method, is 5 by 5 is 25, 26, 27, 28. And then I would do 128, 64, 32, 16. 16 minus 2 is 14. So if I want to start figuring that out, you have to start somewhere, right? Got to start somewhere. So then you draw your lines. This is what everybody is used to figuring things out. They do this whole method, right? So I just said we're using a slash, 28? Okay, so 5 by 5 is 25, 26, 27, 28. Start the bits, 128, 64, 32, 16. I'm jumping in groups of 16. So what's my next number? 16. Jump again, 32. Jump again, 48. Now, I'm not a rocket scientist, but there has to be a number before 48, right? 47. Not a rocket science again, but 31. Same concept. Now, to make things even simpler, there are numbers between those two numbers, right? So there's a 1 through 14, there's 17 through 30, there's 33 through 46, and so on and so forth. This is the net ID, this is the usables, and this is the broadcast. That's the entire subnet for a slash 28 using all your usable IP addresses. It's that fast. So with the slash 24, what happens? Because remember before we had the octets, we had the 8 plus 8 plus 8 plus nothing, right? So we draw our line right there. So how many IP addresses are here? 255, so that gives us a total number of 256 usable IP addresses, not usables, but IP addresses to play with before we get to the broadcast and net ID, right? So in order for us to go up now with the Christmas tree, we have to go in reverse. So when we say, let's say /20, it's just as easy. So now instead of doing the 5 by 5, you have 25. Now you got to think, well, if I go -1, well, that's 24. Well, then all the IP addresses have to be used, so it's 256. So now if I want to go backwards, let's say to a /20, you do the same thing. So you go 5 by 5 is 25, now it's 24, so I got all 256. So then I start counting backwards. 23, 22, 21, 20. 256 times 2 is what? 512, 1024, 2048, and 4096. So it would give us 4096 IP addresses. Minus 2, it gives us 4094 usable IPs. It can be calculated that fast doing the same thing, and it keeps going on as low as the number as you want to go. But the most common ones are 25, 26, 27, 28, 29. Make sense? But to calculate higher, all you gotta do is just reverse the theory and start counting again. But you're still on the same concept of now, instead of halving, going down, now you're multiplying. And it's just that simple. And it's always by the powers of 2. So to give you any kind of equation, let's do a /22. Let's start there. So what's the subnet mask? How do we figure it out? Well, we know that there's 8 bits every single time. There's 8 bits every single time up to 16. Can I go up to 24? Nope, so I need to start with 6. I need a 0. So if I turn on all the bits, it gives me a subnet mask of 255. All the bits, 255. 6 bits. Now to break it down is 128, 64, 32, 16, 8, 4, 2, 1. 1, 2, 3, 4, 5, 6. Draw a line. So what would it be? $252? There's only 3 missing numbers, right? 252.0. Subnet mask or a /22. Just by counting the numbers of the bits that are going to be turned on. So that's the easy portion. When it comes down to the IP addresses, how does all that calculate? So how many usable IP addresses can we get? We did the 5 by 5 is 25, now it's 24, 23, 22. So 512, 1024. We got 1024 IP addresses. Now going back to the theory of drawing your lines with the subnet mask, that helps you. Because number 1, this is going to be 8, this is going to be 16, and then there's 6 usable IP addresses. What's it going to be? It's going to be 252.0. So can we use anything to the left or going up the scale number-wise? No, can't, because they're, so to say, that whole line kind of in the sand's been drawn. So right about here is where you draw your line, and this portion is what we're going to be using for user IP addresses. So that's why you see IP addresses that are in this range, well, unless you have a big company, because that's pretty much the only people that are going to be using those IP addresses. But they have this 1.0 through 255, 2.0 through 255, 3.0 to 255, and 4, and so on and so forth, until you get up to the portion of 4,096 IP. Or, sorry, 23, 22, yeah, 1,054. Make sense? Questions? So you learned the decimal dot notation, decimal dot. You learned the slash notation. You figured out how to do subnet masking to correlate with that. You now know how to break out the actual network, which actually allows you to build any kind of network, and subnet as well. Questions? There you go.